All right, I apologize for the delay. We were having some technical difficulties on our end, but I think we're all set up now. So we'll go ahead and get started. The first thing I just wanted to show you is from yesterday. We did talk a little bit about that. I wanted to go through and show you where things were available on the web, and I'm going to talk about that first. And then a lot of the questions we received yesterday were questions about how do I get on the SMS and how do I access it and about passwords. So I'm also going to talk about that a little bit before I go into some of the cases. So one of the things that you would want to do is we could go to the SERP web page. That is cirp.usace.army.mil. And there's a lot of good information here where you'll be able to actually get to some of the products. This, if you go to the Products tab, you can go underneath, and this actually shows all of our products. But if we go from Products to Gencade, we'll have some information about Gencade available here. The first is actually one of our Gencade executables is located here. Some of the contact information as well as a brief blurb about Gencade. We can also go to the available documentation. This is still under development, but it is a user's guide. So if I go to our wiki page and I go to Gencade, this has a lot of good information here. If we go and scroll down to documentation, if we go to the user's guide, we actually have a great user's guide here. It's not completely updated. The last time we updated it was January of 2012, so earlier this year. But it does have all the information, and the interface has not changed very much at all since then. So we can go ahead and look through here, and you have a lot of information, you have a lot of screenshots, and it gives you all the details about going through SMS in Gencade. We also have information about input and output files, as well as some information about our boundary conditions, wave input. Anything that you would be interested in should be on our documentations section of the Gencade wiki. Another thing I want to mention is if we go to our SERP web page again and go to publications, I do just want to mention a few of the reports that we have out here. If we go under the tab that has 2011, one of our reports, the analysis of dredge material placement, this was a project in Texas that we did last year, and this has one section about Gencade and one section about the CMS. We also have, in 2012, we have two reports that are related to projects that I discussed yesterday. The first is the Phase 1 of the erosion control project at Matagorda County. And then we also have the St. Augustine project that I mentioned yesterday. Also, this is a three-part study, or three-part report, but we have Gencade, which is only specified in the third section of this report. The last thing I do want to mention is the Gencade version 1 model theory and user's guide. This is a technical report we've been working on, and this technically has not been published, but it's still very good. It's going to be published this year, and this is something that will give you a lot of information. In addition to model theory and the user's guide, it also includes an application as well as some standardized benchmark cases. So that's what we have on the website. If we go to Tech Transfer under Webinars, we now have all the information related to this course. So you can click on each one of these and you can see the PDFs. We can also go under each day's material, and in each of these days you can see the simple example. You could zip that file and then actually go through later on some of the examples I'm going to cover today. The next thing I want to explain is how you get to SMS, how you'll actually download it. So I'm going to go to Aquaveo's website, And then I'm going to go to Surface Water Modeling on the right side. And I'm going to go to Free Trial Download. If I go under Beta Releases under the SMS, you'll see SMS 11.1. Depending on what type of computer you have, either download the 32-bit or the 64-bit. One other thing I do want to mention is that we do have a license. We have about 30 licenses that are available in a trial period until December. And we'll write this down in the chat. But the license that you'll have is P as in pig, O as in over, and these are capitals, 84, F as in fire, T as in try, and E as in egg. And all of those, all of the letters are capitals. And this should give you a license, the temporary license, and you should be able to get onto Gencade. I know several of you have been having issues, and I've been sending emails back and forth, and if you are still having problems, let me know and we will get you in touch with technical support so you'll be able to access Gencade in the SMS. All right. So anyway, we're going to continue on. And the next thing I want to talk about is the case from yesterday that I wanted to start. And that was actually an SMS, in SMS. So I'll open up Gencade in the SMS. And the first thing I want to show you is this Matagorda conceptual. And the reason I want to go through this is I first want to show you a little bit more about what would happen if somebody you knew was working with Gencade and they wanted to give you the results of something. So we're going to go ahead and we're going to look at the SMS, we're going to look at the map file, we're going to look at the gen file. We're also going to look at some of the input and output files and see how you can look at the results or make any changes to their work. So the first thing I want to do is just bring in Matagorda, the conceptual model. All right, I'm sorry about that. We had to make a change to our panelists to make sure they can see all of your questions. So I'm back with looking at this Matagorda case. And the first thing that's popped up is, would you like to generate image pyramids? This is related to the aerial photographs, and I'm just going to click no. And it might take a minute to load. So this is what the case would look like in the SMS. And if I bring in an SMS file, it's going to bring in both the conceptual model and the Gencade grid. If you're interested in seeing where this area is located, I can click on the images. And you can see the aerial photograph on top of the grid and on top of the conceptual model. I'm going to unselect this just because it is a little bit easier to see. But with this, bringing it in the SMS, you can see the conceptual model and the Gencade model. If I click off of the copy of the default coverage, you'll see just the Gencade files. So you can see all of this here. And then if I click on Gencade data, again this Gencade menu is going to pop up. And I can go to it, and if I'm interested in looking at this, I can make very quick edits here. I wouldn't suggest you make large edits because it would be more beneficial to make these changes in the conceptual model Because one of the reasons for that is in the conceptual model, if you make changes and convert to your 1D grid, you'll automatically have everything saved. But otherwise, you may not have that information if you're looking at the Gencade data. So you can see all of these edits here. We can look at model control, and then we can look at running Gencade. One of the other things we can do here is now that we have all this, we can also bring it in either the map or through the gen file. So I'm going to do that now. So the next thing I'm going to do is bring in as a map file, because you can also do this as well. And what this actually is going to mean is that we're going to bring in the data in the conceptual model. So this is what the conceptual model looks like. It's not as pretty as the grid, but you can see everything that you need. We have the grid, we have all of the different arcs that we need, and if this is what you're given by somebody that you're working with, you can always just go to right-click on the copy of the default coverage, go Convert, Map to 1D Grid. Your Map to 1D Grid window is going to pop up, and we're going to click OK. And now we've produced the same Gencade file that the person that has actually generated this before would be looking at. The only thing that you would need to do is under Gencade, you'd need to go into Model Control and then set up your model control information. So you'd have to add in your start date, end date, all of your beach setup, seaward boundary conditions, and lateral boundary conditions, because this is one thing that after you convert to a 1D grid, even if it's from a map file, that information is not recorded there, so you just need to re-enter that information. The last thing I want to show you is a little bit more about the .gen file. This is our control file for Gencade. So the first thing, if I'm going to bring it into the SMS, I'm going to go to Edit, to Projection, because we need to have the current projection specified. So in this case, I'm going to click on Global Projection, and I'm going to specify UTM 18, NAD 83, NAD Zone 15, meters, OK, and OK. And now I'm just going to be able to bring in the .gen file. Otherwise, I would get a little error saying that this is not in the convention that SMS has been specified in. So now we have the .gen file in the SMS. So as you'll notice, we don't have a conceptual coverage because that's not saved within the .gen file. And see again the Gencade data, and then we could run the model from here. I do want to go through and open up the .gen file again, just so you have a better understanding of what type of information is in it. The first part shows the files. So this is our .shi, which is our initial shoreline position file. In this case, we do have variable grid resolution. So we have the DX file, which is our .shdx. We also have two wave gauges here. So these are defined as wave 1 and wave 2. As you'll notice that all of these files have the same name, so it's all Matagorda conceptual. So when you save a project as an SMS file, everything else will keep the same name and just have a different extension. And then we also have the PRT file. This is your output file, and you'll specify it. It will be specified within your gen file. You're not going to be making any changes to your .gen file. Everything that you do within the SMS is going to be saved to your .gen file. You don't need to deal with any advanced cards or anything of that sort. I do also want to mention that when you are working and you're developing your .gen file, if you open it up, what will usually happen is instead of just having your name here under each of your files, you're going to have this actual path. So in this case, it would be my H drive, and then this name would be listed before matagorconceptual.shi. One thing to keep in mind is that usually the person who will be using your files will not have all of your information in the same location on their machine as on your machine. So it's a good rule of thumb to delete the path. It's not going to make any difference if you open up a .sms file, but if you're opening up your .gen file, it may not have any idea where that particular file is located on their machine. So we're going to continue on. Under Model Setup, you're going to have your X and Y coordinates of the first point of your Gencade grid, as well as your azimuth, your number of cells. If you have constant cell size, you're going to have an actual number here, but this just defines that we have an additional file called shdx, which refers to variable grid. We also have our simulation start date, end date, K1, K2. Basically, all of your model control information is going to be in this first part of your Gencade grid, or your Gencade file. If we scroll down, in this case we're looking at groins. So you can see we have 3 groins listed, and we have the cells associated with those groins. One thing you might be interested in is we have this YDG. This is actually referring to a distance from your grid. So that would be a really long groin if we were looking at a 3,000 meter long groin. So in this case, this is actually going to be from your grid to the tip of your groin. You'll see the same thing for jetties. So these will actually not be the exact length of your groin from the shoreline to the seaward tip. We continue down, and you can see we have a bypass operation. So we have our starting date, our end date, and then we have our value, which can be positive or negative, determining which is based on whether you're going to be bypassing to or bypassing from. And then we can go down to inlets. So within the gen file, we have our inlet start point, our inlet end point. We also have our attachment and bar locations, and then all the volumes associated with our equilibrium and initial shoal volumes for each of our features. We also have jetties at our inlet, and then you can see the information is just the same as with our groins. I want to go into our other input files now. One of the first ones you saw was your .shi file. Again, this is your initial shoreline data for Gencade file, and this is the distance offset from your grid. So you can see that we're not in any XY coordinates. So this first cell is located over 3,000 meters in distance from your grid. Additionally, we can go into other files, including your shdx. This is referring to our variable grid. So for each one of these cells, it's showing us the size of the grid. So for this first cell, we have a grid cell size of 149 meters. If we scroll down, you can see it's varying, and then our smallest cells are about 25 meters. And then the last input file I want to discuss is the .wave files. These will always be the same. It's going to show all of our data in here. We have the date here. We have the time associated. We have our wave height. Again, it's always going to be in meters. We have our period, and then our direction. And the direction in your wave file is going to be in shore normal convention, regardless of whether you input your data in shore normal. So what Gencade and SMS will do is when you save your files, it's going to automatically convert this when it creates your wave file so that we have our directions in shore normal. So and then those are all of our input files. We also have a lot of output files. I do want to discuss those as well. The first one I'm going to mention is the .mqn file. This is our mean annual net transport rate file, and we have files like this for both our left-directed and right-directed transport. So you're going to see each column represents each cell. So if we scroll all the way to the end, you can see that we have a lot of cells here. This annual transport rate, we have a rate for each cell for each year. So this first value is actually averaging our transport rate over that first year in our simulation. We will have one for each year that we simulate. And then this last value, even though it has the same date as the last date, it's actually averaging over the entire simulation. So it's the average of every date that we're recording. So this is another place where you can get information that you may need. We also have our inlet, the .irv file, which shows you the inlet shoal volumes for your inlet. And in this case, everything is at equilibrium and I don't have any dredging, so the values aren't changing. But over time, if you do specify either dredging or you're moving to equilibrium because your initial is not equal to your equilibrium, we will have a change in the values here. All right, so we also have our .slo file. This is our shoreline position output file. And you're going to see, again, it's in the same format as these other files. This one, you can see each date in our simulation that we have recorded. This represents each cell, and you can see that over time, the values do change. One thing that you might want to do if you're looking at your output and you want to see the results in Microsoft Excel or in MATLAB, there are a couple of different options. And one is that you can actually copy-paste your final shoreline position. So you would copy-paste this value. You would compare it to your initial shorelines that were in your SHI file. And then subtracting between the two, you can see how much shoreline change has occurred over your entire simulation. You have another option there as well. I like to use the .prt file. This is our print file, and it has a lot of good information that you can choose to use or not use. It has a lot more details than the other files. So we start with the initial shoreline position, and if we scroll down, we actually have details for each year in our simulation. So we have our shoreline position after each year and at the end of our simulation. We also have our shoreline change, so it's already calculated there. We can just copy paste that, and then we can actually look at the results. We have our breaking wave angle to the x-axis, offshore wave angle, the breaking wave height, the offshore wave height. We can also look at the gross transport volume for that first year of our simulation, and then the net transport for that first year, and then transport volume to the left and to the right. One more thing that we can do is we can actually look at some of the results for the entire simulation. So if I go and I enter net annual to find, or you can just scroll down, but this is near the end of the file. This represents the transport over the entire simulation, your net transport. We also have the average transport over the entire simulation, leftward transport, and right transport. One other thing that we do have, which we discussed briefly yesterday about the case in Florida at St. John's where they were looking at volumes, we do have these volumetric calculations. So we have the calculated volume change in cubic meters per linear meter, and then we also have it in cubic meters per grid cell. So this is some additional information that we were asked to provide. It wasn't in there originally, but based on a project, we added this to our PRT file. So the last thing I want to show you before we start a real example is I'm going to bring in the .slo file. So I just can drag this in. You can also go File to Open. So, and then one of the things that I like to do is I like to change the display of my initial shoreline and my calculated shoreline. So I can do this by going to Display Options. And then under Display Options, I like to go under Initial Shoreline. I like to make the width a little bit wider. And I like to change the color because these are really similar colors. They're a little hard for me to see. I try to make them bright just so I can see very easily how it compares to your calculated shoreline. So I'll click OK, and I'll go to my current shoreline. I'll do the same thing. I'm going to widen it. I'm going to click on the color, and this time I'm going to make it red, just to make these very easy to see the difference. So I'm going to zoom in on the area of interest. One of the things I do want to mention is you saw when I entered the .slo file into the SMS, we have these time steps that popped up. On your machine, you might not have actual dates, but in order to change this, you would just go to Time Steps, right-click, go to Time Settings, change your 0 time to the first date in your simulation, and then under Time Display, change the display as absolute date/time. So if we wanted to, we could actually step through each time step that we have recorded in the entire simulation. Or we can just look at the last date. In that case, you would just scroll to the bottom and you'd see what the shoreline looks like calculated compared to your initial shoreline. Another option is that you could actually do a film loop if you wanted to see that. So you could go Data to Film Loop, and then you would have your setup, your general options, and you would just go to Next and you would develop your film loop. One other thing that you can do with Gencade is you can go to Display to Plot Wizard. And if I go under Plot Wizard to Gencade Shoreline, go to Next, I'm going to go under Time Step, and I'm going to change this to the specified time step. I'm going to scroll all the way down to the last time step and click Finish. And now I actually have the shoreline in a plot. Now this is the shoreline, so this is the offset distance from your grid. So you can see these values are really large. If I go to Shoreline Change, you'll see that they will change. This is how the shoreline has changed over time compared to that initial shoreline. And you can see where our groins are located and then where our inlet's located. Now this is not going to be the best format for something that you'd want to use for maybe a report or something like that, but it's really quick and easy to see if your results are making sense or not. One thing to mention is that this is your distance from the beginning point on your grid. So in this case, this point is actually to the northeast, and we're moving to the southwest. So it's actually based on what you're looking at, it would be in a different direction. But you can sort of understand where this is coming from. You can see what your values are, and then you can easily just add it to another type, either MATLAB or Microsoft Excel, if you want to look at these in more detail. So that's just a simple way that you can. I wanted to show you this first before I started getting into the SMS. And the main reason I wanted to do this is just so you'd get a better understanding of what things look like in Gencade before we actually dive in and start working with it. There can be times that somebody that you're working with may already be working with Gencade and they'll just transfer those files over to you. So I just wanted you to be able to see what you can do with the results and how you would make changes to those files if that was necessary. So I'm going to go ahead and start the simple example. And what we have here is if we go back to the SERP webpage, I'm going to show you again where this is located if you want to download. I'm going to go to Tech Transfer, to Webinars, to Gencade. We have a PDF, which could be something that you could follow through on your own and set it up on your own. We also have under Day 1 material, we have the simple example where we have the version 1 executable. We have a zip file with all of the files that you would need for this simple example, and then also a guide is here. So if I go under simple example, if you unzip the simple example, you would get something that looks like this, where you'll have a couple of text files. You'll also have this coastline file, and then you'll have actually some results in here if you wanted to compare your work to our examples. I should also mention at this time, if you do have Gencade up and running in the SMS, you may want to go through and follow along. I think I'm going to be working slow enough that you will be able to follow along on your own machine. But if you don't, that's fine. It's not required, but just another option if you do have that capability in your office. So I'm going to go ahead and get started at the very beginning. So what we're considering is this is the first time we've started using SMS 11.1. So the first thing we want to do is actually define that we want to use Gencade. So in this case, we're going to go to Edit. We're going to go all the way down to Preferences. Under SMS Preferences, we're going to click on File Locations. So now we have a listing of all the different model executables, and we're going to scroll all the way down. Gencade is near the bottom, and we're going to find the location of the executable. And I've just recently downloaded the most recent version of 11.1, so that's the beta release. So in this case, this is what you would go ahead and do. This Gencade executable is located under Program Files. You'll go to the SMS 11.1, and then under their Models folder, there will actually be our most recent executable, which is version 1, release 3. And version 1, release 3, and version 1, release 1 are very similar. We only had one slight change that's related to T-groins, so you shouldn't even see changes if you use either executable. So I would click Open, and then I'm going to click OK, and you'll see that the executable is available here. And OK again, and now if you wanted to run Gencade, you'd be able to do that and you wouldn't have any issues. The first thing we're going to go ahead and do is define the coverage as Gencade. So we're going to go to Default Coverage. We're going to right-click on the default coverage. We're going to go all the way down to Type, and then we're going to go to Models, and we're going to click on Gencade. Now if we go back and look through this again, you can see that Gencade is selected. It's checked. The next thing we want to do is start bringing, well actually before we bring in our initial files, we do want to specify the projection. And in this case, we would just go to Edit, Projection. But in this case, this is a very simple example. It doesn't have really any real projection. It's not a location. We're not considering any aerial photographs. So I'm just going to leave the projection as the local projection, U.S. survey feet. If you had another case, you would go to the global projection and then you would define it. And we'll do that in the next case so you can see it. So I'm just going to click OK here. I'm going to go under the example, and then the first thing we want to do is bring in the initial shoreline. And we can do this by going to this .cst, which is your coastline file. I'm going to open it up so you can see it. And this is a very simplified file. So first what you'll notice is the first line is coast. This is standard in any .cst file, so you could develop one of these if you choose to. 1 represents that you only have one shoreline in the file. You can actually have multiple shorelines if you choose. 2 represents the number of points, so I have 1 and 2. And 0 means that my shoreline does not close. So if I had 1, then the shoreline would actually wrap back around. So if I had a curved shoreline, we would actually have a straight line between each end of the shoreline. So you wouldn't want to close it. And then you have your X and Y positions of each point along your shore. So I can either file open to bring this into Gencade, or I can go and bring in the initial .cst by just dragging it in. And as you can see, again, it's just a very straight shoreline. The first thing we're going to do is we're going to define this as our initial shoreline. So to do this, we're going to go to this toolbar here. We're going to click on Select Feature Arc. There are two ways to select your feature arc. The first is to click once and go to Attributes, or you can just double click and it will still take you to that Gencade Arc Attributes menu. This is our initial shoreline, so we're going to define this as the initial shoreline and click OK. And you'll notice that it turns green, representing that we do have an initial shoreline now. The next thing we want to do in this case is draw our groin, because that's the only other thing that we have in this initial file, or in this simple case. So what we want to do, and in this case it's very idealized, so we're going to have the groin in the center of the grid. I should mention that we just have the initial shoreline here. I'm going to be drawing the groin in this direction here. So this is going to be landward of the shoreline, and to the south is seaward of the shoreline. So based on that orientation, our grid is going to be drawn to the north of the shoreline, because the way Gencade works, if we're walking along the grid from here to here, you'll be able to see that the shoreline is going to be to your left. So I just want to draw the groin at a central location in this particular case. So to do that, I want to go to Create Feature Arc, and I'm just going to draw the groin. And one thing you'll see is, say we're not very careful about how we draw this, and we click, you'll notice that we've intersected the initial shoreline. So if we click on this, you'll see we've separated it. If you were to go ahead and set up your grid now, it would only understand that one of those particular arcs is your initial shoreline, so you'd only get half of your grid set up. So in order to fix this, the first thing we're going to do is delete the groin. So we just click on it, hit delete, and then say yes. But now we do have this point here. We need to remove that, or at least change it to a vertex. This is done by clicking on Select Feature Point, highlighting it, then we'll go up to Feature Objects, Vertices to Nodes, and now we have it as a vertex. If we click on the arc, you'll see it's all one arc now. So that's how you can fix it. So I'm just going to go ahead and draw my groin now, and I'm not going to draw it all the way to the initial shoreline. One thing, since this is an idealized case, I do have a certain location of this groin. Because I do want it in the center, I can change this by clicking on each point and actually updating the X and Y coordinates. So I want to have this in the center of my grid, which would be at negative 10,000 feet. And then I'm going to change my Y value as well. This point is actually not that important, the location, or I guess I would say the distance from your shoreline, but this second point will be more important. So I'm going to define this as negative 10,000, and then I'm going to define the Y as negative 300. Because what this is going to say is now the groin is 300 feet long from your shoreline. So that's something that if you don't have aerial photos, you will have to make some type of a measurement to determine if your groins are the proper length. So now I have this in the right location and the distances are the way that I want them. I can go ahead again and go to Select Feature Arc. I'm going to double click on this arc and I'm going to define it as a groin. If I go to Attributes, this window is going to pop up and we can define our permeability check whether it's diffracting or not, and then define my seaward depth. So in this case, we have a permeability of 0.3. We are going to say it's diffracting, and we're going to have a seaward depth of 5 feet. We'll click OK. We'll click OK again. And now the arc representing the groin has turned blue. At this point, I am going to save now just because it's highly unlikely that we'll have any problems with the SMS crashing, but if it does happen, we don't want to have to start from scratch. So I'm going to go ahead and go File to Save. I'm going to name this October 17th. And I'm going to name this one "15 degrees." And then click Save. And you'll notice that when I save this particular file, since I haven't done anything yet, I have not converted from my conceptual model, we just have a map file and the SMS project file available. None of my Gencade files have been created yet. The next thing I want to do is develop the grid frame. And the reason I'm going to develop this grid frame first is because this is idolized, our waves are idolized, so they are in shore normal convention. So we need to develop our grid first, and then we'll go back and set up all your wave information next. So again, if you remember, our grid is going to be located to the north of the shoreline. So to develop your grid, you need to go to this, which is your Create 1D Grid Frame. I'll click on that, and to draw your line, you'll click once. We'll scroll over to where we want to end it, and then you just double-click to end your arc representing your grid. One thing to keep in mind is you don't want to have your grid extend further than your shoreline, because if we extend our grid goes further than our shoreline. Once we convert to our Gencade grid, there will be no initial shoreline in some of our cells, so we'll just have the shoreline go to 0, which would be considered as the grid, and you'll tell right away that this is not how the model needs to work. You need to have a shoreline in all those cells. So we're going to go ahead and click Select 1D Grid Frame, and if you remember, this rectangle is going to pop up. I can either double-click on it or click once and go to Properties. And now I'm going to have the Grid Frame Properties window open up, and we're going to define the location of our origin X and origin Y. This origin X and origin Y is the first position on your grid, which is right here on your right. So in this case, I'm going to define my origin X as 0, my origin Y as 500, my angle is correct, and then the eye size is going to be 20,000 feet. I'm going to change my cell size to 100, and then I'm going to click OK. I do want to talk a little bit very quickly about the difference between your angle and your azimuth, and this is explained really well on our wiki page. So if I go to Gencade, I go all the way to the bottom to Documentation, and I go to Wave Input, and I scroll down. I actually have a little graphic that shows you the difference between the two. So in this case, in the conceptual model, we have angles. This is from this point here. So for this case, this one angle for your grid, we're looking at a 240-degree angle. This is equivalent to the Gencade sign convention, which is your azimuth, to 210 degrees. So they mean the same thing. It's just a little confusing because we have two ways that we get these numbers, the angle and then the azimuth. The azimuth at 210 degrees is actually what you're going to use if you're determining shore normal convention on your own outside of the SMS. So we'll continue on. Now we've developed our Gencade grid, but we have not converted to the grid itself. I'm going to click and add the information for our wave gauge now, but I'm not going to be able to add all of it in. So I'm going to just add a point at the location here. It doesn't matter how far offshore you put your wave gauges, because the only way Gencade knows how far offshore they are is based on the depth that you enter. But your distance alongshore will make a difference. So we're going to click on the point, and I'm just going to change this so it's equivalent to the distance alongshore of your groin. So it's 10,000 feet, so I've moved it slightly. This distance offshore really doesn't make a difference. If I double click on the point, you'll see two things. This actually gives you the opportunity to do refine points, so your variable grid, or you can enter your wave gauge information. So I'm going to enter my wave gauge by checking wave gauge, and I'm going to go to options, and then I can enter my distance or my depth. And then in this case, our depth is 50. And then you'll notice if we click on data, right now, since we have no grid set up in Gencade, we only have meteorologic, oceanographic, and Cartesian convention. So I'm going to get out of this because I know that I'm in shore normal convention and I can't input my data yet. So I'm going to click OK, and it will remember the depth. And I'll click OK. So it is showing that it is a wave gauge, it just has no data associated with that wave gauge. One other thing you may want to do is this icon represents the frame. If you click it, it will zoom out so you can see everything within your window. So now I'm actually going to convert to my 1D grid, and this will develop the grid, and then we'll be able to go through and actually we'll be able to import our data. So I'm going to go to default coverage. So I'll right click here. I'm going to go to type, or I'm going to go to convert map to 1D grid. This map to 1D grid window is going to pop up. I'm going to click OK. And now we have a constant cell spacing grid. I can do two things. I can even delete this grid because we haven't entered everything into it. So I will just go ahead, right click on Gencade grid, and actually delete it. It doesn't even need to be there, but Gencade now knows what your grid orientation is. So if I make sure I have the select feature point selected, and I double click on the refine point window, I go to wave gauge, and under options, I again have the depth here that we've already defined, and I go to data. You'll notice now we have shore normal convention within our conventions. You'll click shore normal convention first. I'm going to go to import, and now I can import one of these wave files. And in this case, I'm going to enter waves. I'm going to click next, and then I'm going to enter what type this is. So this will be the date. We're going to list, this is the time. We have the height. We have the period. And we have the direction. And we'll click Finish. This window is going to pop up asking you to choose the angle convention of the directions. You need to keep it the same as what you specified here, so it's shore normal. It will take you a minute to get it loaded. And now all the information is in the correct locations here, and now all this data will be remembered by Gencade. You can also copy-paste, but if you do copy-paste, you need to have it in this format. So it would need to be your date or your day, your month, your year, and then in the same, if you're using Excel, it would need to be in the same cell that you have your date or your time, and then you'd have to have these columns as well, but it would need to be in that specific format. So I'll click OK. I'll click OK again, and OK again. And what you'll notice here is that we actually have a direction associated with your wave gauge. This direction refers to the first date, the direction of your first date. So in this case, it's all constant. It's going to be idleized. So this is actually the direction of all of your waves. So now we can go ahead and go back to your Gencade grid. So again, we're going to go to default coverage. We're going to go to convert to 1D grid. This window is going to pop up again. I'm going to click OK. And now everything's in Gencade. If I click on Gencade data, we can go to the Gencade menu. And we're going to start defining some of our model control parameters. First, under model setup, I want to enter my start date and my end date. To enter your start date, you would click on the first number. And for this case, I want it to start on January 1st, 1970. So I will type a 1. Then I'm going to push the right arrow on my keyboard to move to October. And then I would actually type 1 to represent January. So I wouldn't try to type in the name of the month. Hit the right arrow again and go to 1970. Hit the right arrow again. I'm going to start it at midnight. And then hit the down arrow to go to AM. To get to the end date, hit Tab, and that will take you to the next line. Now I want to end the simulation on the 31st of December, 1974. So I'll go ahead and type 31, type a 12 to represent December, and then go to 1974. I'll change this to midnight again. Then I'm going to enter my time step, and in this case, it's a half-hour time step, and I just want to keep the recording time step the same. Under Beach Setup, we have all the information here. We're actually going to keep all of the defaults, but I just want to quickly go through each one of these setup tabs. So this is where you would enter your effective grain size, your average berm height, your closure depth, and your longshore sand transport calibration coefficients, K1 and K2. Under your seaward boundary condition, you can enter any input wave adjustments. And then under other options, you can enter iSmooth, which is the number of cells in the offshore contour smoothing window. Then we'll go to lateral boundary condition, and this is where you can enter what type of boundary condition we're using. We have the option to have pinned, gated, or moving, but I'm just going to leave this as pinned in this case. And I'm going to click OK. I'm going to go ahead and resave. So now we have everything saved. If I go back into this file, you'll notice now we have a couple more files that have been set up. We have the .gen file, we have the .shi file, and we have the one wave gauge. So now that we have everything set up, we can go to Gencade and we can go to Run Gencade. And it will just take a minute or two to run this case. Alright, so the model is now completed, and it took us less than a minute to run. I'm going to click Exit, And you'll see here, now we have all the output files in this folder. There are a couple more things I want to do before we look at the results, and I just want to show those to you fairly quickly. You can make changes to your setup in Gencade, and we can do this in two separate ways. I prefer to do everything in the conceptual model, but one thing that you can do is you can go to your Gencade grid, and one thing you might want to do is change the permeability of the groin. So this can be done by going to Gencade, to groins, and you can actually change your permeability here. I usually choose not to do it because sometimes you forget that you've done it, and if you convert back from your conceptual model, you may forget and you may actually have a grid that you didn't realize. So I'm going to click cancel, and what I'm actually going to do now is I'm going to make the change in the conceptual model. So I'm going to click on default coverage, click on the select feature arc, and double click. If I go back to the groin attributes, I'm going to change the permeability to 0.6 here, and then click OK, and OK again. If I go back to the default coverage and I convert map to 1D grid again, this window is going to pop up, and I'm going to click OK. And you'll notice that when we go to Gencade again, under groins, the permeability has changed. So very quickly, we need to go back to the model control, and we need to make these changes again because it doesn't remember these as we reconvert. So we're going to go again, January 1st, 1970 at midnight to December 31st, 1974 at midnight, and we're going to change the time step to a half an hour, and we're going to click OK. I'm going to save this in another file, and then I'm going to go Gencade to run Gencade, and then I can run this case again, and this will take just a minute. All right, so now we've exited again. The last thing I want to show you is very similar to what we just did, but say we want to change the direction of our waves. So we can go ahead again and go to default coverage. We're going to click on select feature point, and we're going to go back to wave gauge. We'll click on options, and we're going to keep the depth the same. We go to data. We already have data in there, but I'm going to change the direction. So I'm going to go back to import, and I'm going to go to this 10-degree wave, and then I'm going to define each of these. So we have the date, the time, the height, the period, and the direction. I'll click Finish. We want to keep this as shore normal. I'm going to click OK. We'll load in all the wave events. And click OK, OK, OK. So you can see now the arrows change direction based on the new direction we have in our wave events. If we go back to default coverage You go to Convert, Map to 1D Grid. This window is going to pop up again. We're going to click OK. If I go to Gencade to edit wave data, and I click on the data here, you're going to see that the direction has changed to 10 degrees. I'm going to click OK. Now I'm going to go back to the model control, and I'm going to change the date and time again. Just the same way as I've done before. And now I'm going to save the new file. One thing actually to keep in mind is that in this case, we still have the groin permeability at 0.6. Even though I usually do everything in the conceptual model, I'm just going to change this back to 0.3 just because I want to make a comparison to the original 0.3 case. So I'm going to click OK. Now we have the change. And now I'm going to save it in a new folder. Click Save. And now we'll go Gencade to run Gencade again. All right, so now we've finished that application. I do want to show you a comparison between the three, and then I want to show you very quickly how we'll define variable grid resolution before we go to a more complex example. So I'm going to bring in each of these cases. So I can bring in multiple .slo files. So I'm going to bring in this first one here. I'm going to compare it to the 15-degree wave angle. And I'm going to compare it to this one as well, the permeability of 0.6 at a 15-degree angle. I'm going to go again to display options, and I'm going to change the color and the width of each of these lines just to make it more easily readable. All right, now so now we have larger lines and they're in brighter colors. If I scroll all the way down to the bottom, we can compare all three. So I'm going to zoom in on this, and you're going to see this first case. This is with the permeability of 0.3 and a wave angle at 10 degrees. This is the wave angle at 15 degrees, so you can see how we have a change in the shoreline. And then this is the 0.6 permeability with the 15-degree wave angle. So you can just see very quickly how they do have different results. The last thing I want to show you is how you would develop the variable grid. So we're going to go back into this original case, and I'm going to bring it back into the SMS. So I want to make the variable grid resolution, we want to make the smallest cell sizes closest to the groin. So we're going to go ahead and do this. We're going to just draw a point here. So we're going to create a feature point, and we're just going to click here. I want to make sure it's at the exact location of the groin. So I'm going to change this to a negative 10,000. So I moved it slightly over. Then we're going to go in and click on Select Feature Point, and we're going to click on this point. We're going to click on Refine Grid in the I direction, and we're going to change our base cell size. And we're going to change this base cell size to 25. And click OK. Now we're going to go back to Default Coverage, Convert, Map to 1D Grid, and the window is going to pop up again. Now instead of defining the cell size, we want to say Use Refine Points. I'm going to click on this, and now all these options are available. We're going to change the maximum cell size to 100. We're going to keep the maximum bias as 1.1. And what this means is that this is the rate that we're increasing each cell adjacent to the smaller cell. So if our starting cell size is 25 feet, we're going to increase 10% from that cell to the cells adjacent until we reach 100 feet. And then the rest of the cells will be that constant maximum cell size. We also have the option to either use inner growth or not to check that. What this means is if you have two refined points and inside you want to have all the cells the same spacing, you would unclick the Use Inner Growth, because what this means is if you have multiple cells and you have 2 points, inside of those will actually have growth of the cell size there. So instead of being constant, we would grow from 25 to 100, and if these cells are far enough apart, we may actually grow to the maximum cell size between. So that's what Use Inner Growth means. And we're going to click OK. And you can see how this actually changes. I'm not going to go ahead and run it since this has been taking quite a bit of time, but this is what it looks like. I do want to just set it up quickly so you can see one thing. I want you to notice that when I save, you're going to notice if I go to the file, you'll see again the .shdx file, and you can see how we have in that one little area, we have a variation in our cell size. Another thing to keep in mind is that when you do have variable grid resolution, you will have a different number of cells, and the cells associated with each of our features will be different. So we have the .gen file of the variable grid shown here. We can also look at this case. We can open up the file, and you'll notice one of the first things is that our wave location, even though it's in the same location, the cell associated with that wave gauge is different. And then if we notice, we have 200 cells with constant cell size, but since we've dropped the cell size near the groin, now in this case we have 216. So that's just something to keep in mind, that to compare these two cases, you wouldn't be able to open both in the same Gencade grid and compare the .slo files in the SMS. You would have to check them out separately, but you can always use the .shdx file so you would know how large each of your cells is, and then outside of the SMS you could do a comparison. So I'm going to conclude the simple example. This one really was just to give you a better idea of how you can do something very simple in Gencade. It's not related to a real case of any sort, but it's just to give you a better idea of what the files mean, how you input information, how you can bring your wave gauge information, and how you run Gencade. Now I want to get to a case that's slightly more complex, and this is in North Carolina. It's one of our grids from Onslow Bay. So I'm going to go ahead and close up the SMS and delete my existing data, and then I'm going to start this next case. And this one is going to include a couple of inlets. It's going to include a right jetty on one of the inlets, several beach fills, multiple wave gauges, and we also have a regional contour in this case. And since this is a real location, we're going to bring in an aerial photo so we can see what the location actually looks like. And then we'll go through this setup, and then we can actually run it. I don't think, since we are a little behind on time, that I will run it, but I will show you what the results look like. And you again can find that on the Gencade page on the SERP webpage. We do have all the files, so if you do want to follow along or work on these later, you can find all of the necessary files that you would input in a Gencade. You can also find our input and output files, so if you've noticed that your results look different, you can see maybe if you input something in the wrong location and why it looks a little different from our results. So I'm going to go back to day 2. You'll have this onslow.zip. You'll just unzip, and once you do that, you're going to have all these files here. You'll have your aerial photos, you'll have your initial shoreline, you'll have the regional contour, you'll have your waves, and then I have the input and output files listed separately. So the first thing that you would do, just to remind you, we would not need to do this if you've already worked in the SMS on your machine. But again, just as a reminder, you would go Edit, to Preferences, to File Locations, and you would define the location of the Gencade model. Once that's done, we can start setting up in the SMS. And the first thing I want to do here is set up my projection. And to do this, I'm going to go Edit, to Projection, and instead of having a local projection, I'm going to click on Global Projection. The Select Projection window is going to pop up, and in this case, I'm using State Plane. So I'm going to scroll up and click on State Plane Coordinate System. And now we have the zone. It's already set up for this case. It's the zone North Carolina, datum's NAD 83, and we're in feet. So I'll click OK. The vertical projection, this is local, and we'll keep U.S. Survey feet, and we'll click OK. So now we have the proper projection. The next thing I want to do is start bringing in your initial shoreline and your regional contour. So we'll enter the initial shoreline first, but in order to do that, remember we need to define that this is going to be a Gencade project. So we'll go to our default coverage, we'll right-click on default coverage, scroll down to Type, go to Models, and then define as Gencade. So I'm going to go under Initial, the initial folder, and I'm going to bring in the 1997 initial.cst file. So now again, it's just a black line. It doesn't know what this is defined as. It's just defined as generic. So we're again going to go to Select Feature Arc, and I can double click on the line, and I'm going to change under Arc Options from Generic to Initial Shoreline and click OK. And again, it's going to turn green. The next thing I need to do is define my regional contour. And again, your regional contour could be one shoreline, it could be multiple shorelines, it could also be an offshore contour. It's just telling Gencade that over time, instead of conforming to a straight line, you want your shoreline to conform to the shape of your regional contour. So what we're going to do is we want to go to Map Data, we're going to right-click, we're going to go to New Coverage, and then under the New Coverage window, we're going to scroll down to Gencade. And then I'm going to name the coverage. I usually just call it regional contour, just to define what we're looking at instead of having default coverage 1 to new coverage. It's just a little bit easier so you know what your coverage is representing. So I'll click OK, and now we have a new coverage. It's Gencade coverage, but we don't have anything in it. So I'm going to bring in the regional contour. So I just need to drag in the regional contour.cst. And now we have another line represented in black because it's just a generic arc. So again, this does get a little repetitive, but we're going to go back to Select Feature Arc. We're going to double click on the line, and we're going to go to Regional Contour. And then we'll click OK. So now we have the regional contour in blue. But as you'll notice, we're in two different coverages. So we need to merge these two coverages into our final coverage, which we're going to use to set up all the other arcs and develop everything else in this grid. So in order to select both the default coverage, which again is our initial shoreline, and our regional contour coverage, we're going to click Default Coverage, and we're going to click the Control button and then click on the regional contour. This will allow you to highlight both of them. And then we're going to go to right-click and go to Merge Coverages. Again, we're going to get this warning saying, do you want to delete the coverages used to make the merge coverage? I usually say no. I just like to have all the other coverages available in case I want to go back to them at any point in time. So I'll click no, and that will leave them as they are. If I click on Merge Coverage, and I zoom into this point here, you can see now we have both the initial shoreline and the regional contour in one coverage. The next thing I want to go ahead and do is import the aerial photograph. And this, for the most part, is just going to be very simple. We'll just go to the aerial photo, and I'll bring it in. So in this case, you can see it here. One thing to keep in mind is in this case, we can go under Images and right-click, and we can look at the projection. So in this case, the projection of this aerial photograph is actually in a different projection, but it's being converted in the SMS so it knows the location in state plane. So now that we have our shorelines and we also have our aerial photograph, I'm going to go ahead and start defining my inlets. And for this case, we're only doing our northeastern grid. This was our grid that included Beaufort Inlet and Bogue Inlet. So I'm just going to do those two inlets now. So if I scroll in, I'm going to scroll into Beaufort Inlet. I'm going to click on the Create Feature Arc, and I can just draw a line from both sides of the inlet. I try to get it as close to the shorelines as I can without intersecting them, just because this gives you the best chance of having your shoreline or having your inlet in exactly the location that you want. If you have a large cell spacing, it's possible that if you draw the inlet back here or further out to sea, that we're actually not going to, what's going to happen in some cases is your inlet may have cells that are associated with it that might not be correct. So then when you go into your Gencade model, you may see that for some reason your inlet is expanding to here instead of from just here to here. So I'm just going to go ahead and draw the inlet. We're going to go back to Select Feature Arc, and I'm going to double click on it. Now I'm going to go to Inlet and go to Attributes. First thing I want to do is just name this inlet as Beaufort. Now I can define the volumes. So this is where I would input all of my shoal volumes, initial, and equilibrium. So I'm going to go ahead and do that now. And you'll notice that both the ebb and the flood shoal are in equilibrium. So now we have the left bypass. The left attachment, the right bypass, and then the right attachment. And then I'll click OK. The next thing we can do is we can actually input dredging events. And now this inlet, in reality, it has a lot of dredging events. It occurs every year. But in order to not be overly repetitive, I'm just going to show you 2 of the dredging events. So I'm going to start under begin date. And this works the same way as under your start and end date for the simulation. You would input the information in the same way. Another option is you can actually click on this arrow here, and you can change the date here. I usually find it just easier just to type these values in, the dates. So I want to start my first dredging event on July 1st, 1997. So I'll just type that in. And it's going to end on September 1st, 1997. If I go to shoal to be mined, we have all the different options from your left and right bypass and attachment bars, as well as your ebb and flood shoals. In this case, we're going to choose the right bypass, and we have a volume of 187,359. If I click Tab again, it'll just drop me down to the next event. In here, I'm going to have the same dates. So again, it's going to be July 1st, 1997. And then if I click Tab again, it's actually going to give us a new event at the bottom. So you have your 2 events. It might show that you have a third one, but it actually doesn't remember that because it doesn't have full information. So now we have September 1st, 1997. We can click here under shoal to be mined. Now we're going to call this the left bypass. And the volume is 80,297. Now I'll click OK, OK, and OK. So now we have an inlet at this location. I'm going to save now just to make sure that we don't lose this for any reason. So I'm going to go to Save As. And just save it in a file. So now we have this saved, so at least if something occurred, we could go back to this point and we wouldn't have to start at the very beginning. The next thing we have, which is a little difficult to see, is we actually have a jetty located right here. And because I know there is a jetty there, I'm actually going to modify this right point just so I don't overlap the jetty. So I'm just going to click here and just change the location of this point. And then since I'm crossing over, it doesn't matter, but I am just going to move this to here. So we have the inlet defined, and we're not crossing over any of the other arcs. So now I'm going to draw and represent the jetty. So I can just start my jetty here, cross over both here and here, and then finish my arc here. If you want to remember, this is actually going to be considered your right jetty on the inlet, because you need to consider in this case, our grid is going to run from here in this vicinity to your northwest. So if you consider that you're sitting in the inlet here and you're looking out onto into Onslow Bay, you'll be looking to your south, and the jetty, the west jetty, is going to be on your right, so that is going to be your right jetty on the inlet. So in order to specify everything for Gencade, you need to click the Select Feature Arc. We're going to double click, and we're going to go to Right Jetty on Inlet. We're going to define the attributes. Here we define permeability, diffracting, and the seaward depth. So for this jetty, we're going to define as permeability as 0.5. We're going to say diffracting, and it's a seaward depth of 5 feet. Now as a demo, the distance, at least for me, offshore is not as important. If you're doing a real case, you will have to specify the real distance offshore, so this would have to be in the correct location. Our aerial photograph is not that clear, so you can't actually see where it is located. But when we did this case for our project, we did make sure we had the specific location of our groin specified. The next thing we want to do is go back and define bogue inlet. So I'm just going to go back to the frame and go all the way out here and then scroll back in. Because once we have images loaded, particularly these large images, it is a little difficult to go left and right. So I'm going to scroll in, and then here we have bogue inlet. And again, I'm going to do the same thing I did at Beaufort. I'm going to click on Create Feature Arc, and then I'm actually going to draw from this side to the other side. And you'll click once at the start and then double click to finish your line. If you click once, that will cause you to have a vertex like you would see here. So we're going to go to Select Feature Arc. I'm going to double click, and I'm going to go again for Arc Options to Inlet. I'm going to go to Attributes, and I'm going to name this Bogue. If you wanted to name this Bogue Inlet, make sure you don't have a space, so you would just say Bogue Inlet. But I'm just going to leave it named as Bogue. And now I have to enter all my inlet shoal volume information for Bogue. And this one we don't have as much information on. So all of our shoals are in equilibrium. So you'll see that here. $425,000 is going to be our initial and equilibrium volume for all of our bypassing bars and our attachment bars. And in this case, we don't have any dredging events, and so we don't need to add anything to dredging. We'll click OK, and we'll click OK again, and now we have our inlet defined as Bogue Inlet at that location. The next thing we want to go ahead and do is add some beach fills. So I'm going to go ahead and just scroll out again and then go back. In this case, we have several beach fills on Bogue banks. We actually, I believe it's 7. We have 7 beach fills. And I'm not going to draw them in the exactly correct locations just because we don't have that much time. But I am going to show you how to draw each one of them. So what has happened in this case is that we have one beach fill located here. And this is just, it's going to be a little bit into the ocean, but it would really be just along the shore. But the distance offshore really doesn't make that much of a difference for your beach fills. You can draw it in any location whatsoever. You just need to make sure that based on the angle of your grid that it's not offset so much from the shore that it gives you an incorrect location. So we have one beach fill located there. We also have another beach fill in the same location at a different date. So I'll draw that. We'll extend this one to here. So that's a third beach fill. We're going to keep extending it to here. Now I'm going to scroll over slightly. And I'm going to extend my beach fill again to here. And then I'm going to draw my last beach fill. So they're all connected, but they are connected as actual points instead of vertices. So these are separate beach fill events. We're also going to have a second beach fill event that's going to be located from here to here. So now we just have lines representing our beach fills, but we need to add the information here. So we can do that in the same way as we've done before by just going to the Create Feature Arc, and we can click on each. Let me scroll back just slightly so you can see all of our beach fills. So in this first case, we're going to go to Beach Fill Event, click on Attributes, and now this is going to be similar to the dredging, except we have a beginning date and end date, but we have the added berm width instead of the dredging amount. So here, we're going to define this as starting on November 1st of 2004, and it's going to end on December 1st, 2004. And then we're going to have an added berm width of 84, and we'll click OK. And then the beach fills are going to turn green. So we're going to do that for each one of our beach fills. So for this second event, this is going to occur from July 1st, 2002 to August 1st, 2002. So we'll just enter that here. And then we're going to have an added berm width of 37 feet. Then we're going to go to this third beach fill event, name it Beach Fill Event, go to Attributes, and then this third event occurred from November 1st, 2004 to December 1st, 2004. So we'll name that. And then we have an added berm width of 84. All right, so now we can do our fourth event. We're again going to go to our beach fill event. We'll go to Attributes. This one occurred from July 1st, 2002 to August 1st, 2002. So we'll define that information here. And we have an added berm width of 40 feet. And we'll click OK and OK again. Now I know this is getting repetitive, but we just have a couple more to add. So we'll go back to beach fill event. We'll go to attributes. We'll define this one as February 8th, 2004. And then March 23rd, 2004. And then the added berm width is 39. And we'll click OK. And OK again. Second to last one here, it's a beach fill event again. We'll go to attributes. This one is July 1st, 2002 to August 1st, 2002. So we'll define that. And then the added berm width here is going to be 57 feet. I'm going to click OK. OK again. And now the last event. Beach fill event. Go to attributes. And then this one was July 1st, 2003 to September 1st, 2003. So we'll just define that. And then September 1st. And then the added berm width is 51 feet. Okay, and OK. And I'm going to go ahead and save this just to make sure we have everything here. All right, so now we have all the beach fills in. We have all of the inlets, the initial shoreline, and the regional contour. The next thing we want to define are the wave gauges. And in this case, we have our wave gauges, and they're actually in meteorological convention, so we can bring these in before we actually set up our grid. So I'm going to do this based on edit and the single point projection. And what this means is that we're going to bring these in longitude and latitude. So we're not going to be in state plane, we're going to be in geographic. So we're going to go convert from, we're going to change this global, and we're actually going to change this to geographic. And we're going to click OK. And then we're going to go global again, and this is what we're converting to. And we're going to change it to state plane, North Carolina, feet. We'll click OK. And now we can enter our longitude and our latitude. The first wave gauge is located at this longitude and this latitude. And you can see we have our new coordinates here. We're going to click on Create Feature Point and click Close. If you click once, we actually have the location here. So now we have our first wave gauge. And we're going to do this twice more because we have two more wave gauges. So we'll go back to single point projection. This is already defined, so we don't need to say it's geographic and state plane again. It already has that remembered. So we're going to have the longitude for the second point, which is negative 76.83, and then 34.5. We'll create our feature point again and click Close. If I click on any point in this window, it's going to show us where the location of that wave gauge is. And then we'll do it one more time. We'll go to single point projection once again, and then we'll list our third wave gauge, which is at negative 77.08, and the latitude is 34.5. And again, we need to create the feature point and click Close. Clicking again, we have our third wave gauge here. So now we have all three of our wave gauges available, but we haven't defined them as a wave gauge. So we can start with our first one here. And we're going to do that by going to the Select Feature Point and double-clicking on my wave gauge. We're going to define it as a wave gauge and go to Options. And here, this wave gauge is located at 62 feet. We're going to click on Data. And as you notice, we only have the options in oceanographic, meteorologic, and Cartesian. That's fine because we're just going to have them in meteorologic convention. So we're going to go to Import. We're going to go to our WIS data, and this is WIS station 63274. I'm going to bring this in. I'm going to click Next. So again, this is your date, your time, your height, your period, and the direction. And we'll click Finish. We're going to keep this as meteorologic and click OK. And it will take us just a minute to load. So now we've loaded the first wave event. We'll click OK, click OK again, and we'll click OK a third time. And now we have it defined as a wave gauge, and you can see the direction of the first wave event in the listing of information. We're going to do the same thing for a second wave gauge. We're going to click again on wave gauge, go to Options, and this wave gauge is going to be located at 69 feet. We'll go to Data. Again, we're in meteorologic convention. We'll go to Import. We're going to go back under WIS, and this is WIS wave gauge 63276. So we're going to open that. This is all fine, step 1 of 2. We'll click Next. We're going to change this to date, to time, to height, to period, and to direction. We'll click Finish, OK, and we'll wait a minute for it to load. Now it's loaded. We click OK. So now we have the direction of our second wave. And we'll do the same for our third wave gauge. We'll click Wave Gauge. We'll go to Options. We'll change the depth for this one to 56 feet. We'll go to Data. We'll keep the convention as meteorologic. We're going to go to Import. We'll go back to WIS, and we'll open WIS wave gauge 63279. We'll click Next. We're going to say date, time, height, period, and direction. We'll click Finish. We'll click OK, and we'll wait a minute for it to load. And we'll click OK. And I'm just going to save once again. All right, so now we've saved. The next thing we want to do is create our grid frame because we have everything in the conceptual model that we're going to need for this case. We have our inlets, we have our initial shoreline and our regional contour, we have beach fills, we have the right jetty on the inlet, we have our dredging events, and we have our wave gauges. That's all we're going to include in this case. I do want to mention that for this particular example, there are additional dredging events and beach fill events, so this is actually not the calibrated case in case you look at the results and you can tell they're not as, they don't look exactly the same as the results in the presentation you saw yesterday. So the next thing we want to do is create our grid frame. And remember, we go back to the Create 1D Grid Frame. And for this case, again, we're going to start our grid in this location up here, and we're going to extend it to the right or to the west. So this will be north of any of the locations along the shoreline, because remember, if you're walking along the grid from the starting point to the ending point, your shoreline will always be on your left. So I'm just going to create the grid frame, and then I'm going to modify it. So I will click once, I'm going to drag it here, and then I'll finish it here by double-clicking. I'm going to go to the Select 1D Grid Frame, going to double-click on the square, and I'm going to change my origin to this. And then the origin Y is going to be changed to this value. My angle, it's very close to what we've done in this case, but we're going to change this to 190 just to make it a simple, easy number. And we're going to change our eye size to 181,200 feet. The last thing we need to do is define a new cell size, and in this case we're going to change the cell size to 300 feet. And you'll see that the number of cells also changes automatically in this case to 604. And I'll click OK. So now we have all that information in our grid, and you can see that the grid actually moved to the new location. So we're going to convert to a 1D grid. So we'll go to Merge Coverage. We're going to go to Convert, Map to 1D Grid. This Map to 1D Grid window is going to pop up. It should be identical to what we just did in the grid frame properties, and we're going to click OK. And now you can see that we've set up our grid. If we want to remove the image, we'll just click off of it so you don't have it there. We can also, you can see the difference between the grid frame and then the locations of each of our beach fills and our inlets. So you can see for this case that the location of the jetty is a little different. You'll also notice that beach fill events are actually, those are located on your grid. So you won't see them out on the shoreline like you would some of the other features. I'm going to click off the merge coverage so you can just see the grid frame properties. And the next thing I want to do is click on Gencade Data, and I'm going to go to the Gencade menu. One of the things that, basically the only thing that I would change under Edit, under any of these Edit menus, would be to go to Edit Inlets, and then under Position for your cell, for both for inlets, the only thing I might change here is the location of my left and right bypass bars, because you might know that in reality, the bypassing bars are not adjacent to the inlet. They may be located further away, or they may represent more than one cell. So this would be a place where I would change those values if I knew that information. So now we're going to go ahead and click on Model Control, and I'm going to change the model control for this case. Since this was a case we already calibrated, we do have more information than we did in the simple case. So the start date is January 1st, 1997. So I'm going to type this information in. and then the end date is August 27th, 2004. At midnight. We're going to keep our time step at 1 hour, and we're going to have a recording time step of 168 hours. So these are both the defaults. We'll go to our beach setup, and we're going to change our effective grain size to 0.17 millimeters. Our average berm height, in this case, is 4.5 feet, and our closure depth is 26.5 feet. Based on our calibrations, we're going to change K1 to 0.6 and K2 to 0.4. We'll go to our seaward boundary condition. We're not going to make any changes to the input wave adjustments, but we do want to increase the number of cells in our offshore contour smoothing window from 11 to 101, because remember, we need to have this as a positive number and it must be odd. And this will smooth out because we're looking at more regional scale, more on a regional scale than on a local scale. So we're more concerned with smoothing along the entire shoreline. And then for lateral boundary conditions, we're just going to leave the left and the right as pinned. So I'll click OK. So now that we have all that information, I'm going to save it again. I'm going to save. Yes. And we'll just give it a minute. So now we can go back into my file, into my folder, and we can see all of the input files. The only thing that's different between this case and the case I showed previously, the Gencade simple example, is that we have a .shr file, which is shown here. It's in the same format as the .shi file, which is your initial shoreline file. And you can see the offsets from the grid for each of our cells here. And then you'll notice we also have one wave gauge, one .wave file for each of our individual wave gauges. So all that information is in Gencade. We can go ahead and start our simulation. So I'm just going to show you again. You'll go to Run Gencade. The simulation is going to begin. I'm actually going to abort it since we're just about at the end of our session, but I will show you what the results look like very quickly, and you can see how we can view the results in the SMS. So I'm going to go back and show you from our input files. This is what you would have on your computer. I'm going to bring onslow.sms in, and it takes just a minute or two to load. All right, so we have the file here. I'm going to bring in the output files, I'm going to bring in onslow.slo. So first of all, we're going to zoom in, and we're going to remove the merge coverage so we don't need to see that. I'm going to again just change the display really quickly, just as a personal preference. You don't have to do this if you don't want to. So okay, so I already have the time steps set up, but if you're set up not based on a certain zero time, for example, if I had relative time chosen, this is what your time steps would look like. So it's not in a nice format, you don't know what the date is. So we're going to go back, time settings, change this to absolute date and time, and click OK. We can go to each of our inlets, and we can see what's happened over time. So we can see that the initial shoreline is the green, the final shoreline is this red with the blue. I could bring in the aerial photograph, and I can also bring in, I have the final shoreline as well, which we could bring in and do a comparison to. The last thing I want to show here is if you go to display to the plot wizard, again, we can go to Gencade shoreline. we can go to the specific time step. To the last time step, we'll click Finish, and again you can see the shoreline or the shoreline change. And again, this is at the very first point to the northeast of Beaufort Inlet, and then as we move this way, we're actually moving to the west. I also want to show you, because this case we actually had a change in our inlets. If we go to Gencade, Inlet TS, click Next, change this to Beaufort Inlet, have the initial start time, and then we'll choose our end time as the last time. And if, for example, we wanted to look at the left bypass, we can click Finish, and you can see that over time the bypass bar is actually increasing towards equilibrium. So we do see a change in this time series. The last thing I'm going to show you is that I already showed you how you can run Gencade in the SMS, but maybe you want to run 6 Gencade cases on your machine, but you don't want to do everything through the SMS. You would still go ahead and set up everything in the SMS, but you can also run through the command prompt. And this would be done. We have to do 2 things first. We have to make sure all of our files are in one location. We also have to make sure that your executable is in the same location. So I'd have to copy-paste the Gencade executable to this file. Then we would go and open the command prompt. So everything is here. And we're going to show the location. So we need to change the directory. So now we're in that specific directory. We need to list the name of the Gencade executable first. So in this case, it would be Gencade v1 r1.exe, or it could be version 1 release 3 if that's what you're working with. Have a space, and then you'll type in the name of your .gen file, onslow.gen. That's all you need in the command prompt to run. You would just click Enter, and then you would start running in the command prompt, and immediately you'll see your output files starting to be created. I'm not going to go ahead and do that since I haven't put the executable in here, so I would get an error. But this is another way that you can run is through the command prompt. So we are after 3 o'clock today. I think we're just going to finish up now. I really thank you for your time. I apologize for the start of our workshop. We had some technical issues here, but I think we were able to get everything set up. We'll start again tomorrow at the same time at 1 o'clock. We're going to go through the Long Island example. It's a very complex case. One of the things about that is it does have inlets and beach fields, but it also has structures. So I'll probably not include every inlet. So I might just show you one so you can remember how to include inlets, maybe one beach fill, and then we'll move into the structures. After that case is complete, I'm going to talk for a few minutes about some of the new capabilities that we're working on in Gencade, and then Rusty is going to spend some time going over the wave conversion tool, and then we'll conclude with a demo. So I think we will conclude now. I'll look through again if you had any questions, and then tomorrow we'll start the session with any questions that you have. So I appreciate your time, and we'll see you back here at 1 o'clock tomorrow. So hope you all have a good day. Thank you.